So without any overdue, please welcome Austin Griffith.
Okay, how's it going? Good crew. Thank you for having me. Let's get this plugged in and see how it goes. I was thinking maybe we could create a Telegram group like we do for the other ones. Would you mind creating one and I'll make a QR code of it? We can pull people in. Okay, start mirroring. Yes, okay, it worked first try. Phew. Sorry I am late, everyone. We were stuck in Prague traffic. Okay, so I'm Austin Griffith. I started the Buidl Guidl DAO with this front row and second row of people. We focus on developer education and onboarding and tool building in Web3. It's our job to teach you guys how to build on Ethereum and provide resources for you to not just learn, but thrive. And so if you go to Buidl Guidl, it's Buidl Guidl. That's kind of a weird name, but it's buidlguidl.com if you want to find us. And we'll have lots of resources today that we'll provide. Kind of our main piece of curriculum is speedrun Ethereum. So if you're a technical person and you know how to code, you can go to speedrunethereum.com and kind of learn all the stuff there is to learn, including a bunch of different things to build, like NFTs, staking apps, token vendor, a dice game, a DEX. There's a bunch of things that you'll want to build first so you understand like what the heck you even use blockchain for. And the tool that we'll be using is Scaffold-eth. Scaffold-eth is the back end and the front end all packaged together. So when you deploy your contract within Hardhat or Foundry, which are the tools for deploying contracts, they get injected into Next.js. So it's kind of back end and front end all at once, so it helps you build apps quickly. And the team here is building Scaffold-eth, has spent a lot of time making it work well with Cursor. And that's what we'll do. Lots of one-shotting apps and vibe coding and that kind of thing. I honestly don't write a lot of code anymore. And even when I did, it was pretty ugly. Usually I would do a prototype and then someone smarter than me would take it and make it look good, which means that I am the perfect person for vibe coding. So we'll get into that and we'll vibe code in a little bit. But I think one of the biggest questions is, why blockchain? Like, why do we need to use a blockchain? Why can't we just use a database? And to illustrate that, I want to show this. So let's hold a vote. I'd like everybody in here to scan in. Let me make this a little bit bigger. And we're asking the question, how's the vibe? And you get a vote on the vibe. This was an app that I vibe coded with just one prompt. I said, please build me a web application that lets people vote on how's the vibe. Let there be two buttons, good and bad. And here's the kicker. I don't see any good votes. Something tells me that without any good votes, there's something else going on here. I might need to restart my database. We should see at least one vote if we have 18 people here. Just a second. I think I did something wrong. Let's do that and then restart the server real quick. Okay, can anybody vote yet? There we go, now we're seeing votes. Okay, so the prompt was like, let's have good and let's have bad, but I added a little extra thing in when I prompted to build it. I said, if they click on bad, give them a nondescript error that basically censoring. You voted? Oh, Hayden, I can't believe I'm hurt, Hayden. Basically, it says if we're censoring the vote is the point here. If you're using a centralized database, that centralized database can be censored. And of course, asking about the vibe is not that important. But imagine if this was a presidential election or this was some sort of much more important decision that would be made. You wouldn't want any centralized party to be able to censor you. Even though this isn't like directly saying, we won't take bad votes, they just put a little bug in the system and all of a sudden it's 20-0. It's a landslide vote for good, right? And that's just not fair, and that's not how elections should be held. So this is just one property of blockchains. Building on blockchain gives you there's two really important things. First of all, there's this censorship resistance, right? No one can tamper with it and anyone can get to it. And second of all, there's this always-on property of it. Here, let's just do this. Let's say it was counting bad and it looked bad real quick. I could do something like get check. I could break it, basically, right? I could say get checkout master. And all of a sudden now we just have a loading bar. And I'm like, I don't know why it's broken, right? So this is the other thing, is a centralized application can fall over. If you build apps on Ethereum, those apps will be on all the time. In fact, Ethereum has not gone down for a decade. It's been up for 10 years straight. And any app that runs on Ethereum has also been up for 10 years straight. So always on and censorship resistant. These are the two most important properties of building on a blockchain. And you don't always need that level, right? If we're just asking what the vibe is, I could probably just ask for a hand count here, right? But as you get into more important things like elections and governments, and as we have wars all throughout the world, there are competing people that are adversarial, and a blockchain is the perfect thing to put between them to help them coordinate, because neither of them can tamper with it, neither of them host it, can take it down. Not even North Korea can take it down. So these are the two important properties of blockchain. Now, there's actually a third thing that we're not talking about that is kind of like a combo move or a superpower of blockchain. And that is, once you deploy your app to a blockchain, or if you want to build on blockchain, it's permissionless. It's open source. Anybody can get to it, and it's very composable. If I make an NFT app, you can make another app that requires that NFT, and you don't have to ask me permission to use my components. So anything that's deployed to Ethereum is accessible to everyone else to build on top of. So if you build a primitive component, a lot of other people can use that primitive component without ever having to talk to you or get your permission or anything like that. So you've got always on, and you've got censorship resistant, but you also have this third property of composability and open source, which makes this a very powerful platform. I started building apps all the way back when Facebook had an app store. And this is a very similar situation where there's this kind of world app store you can build on top of Ethereum, and you're programming money. So if you're programming money, there's a lot of revenue to be had if you can find it in the right place. But also there's a lot of scammers, and there's a lot of toxicity in this space, and you have to have thick skin. So yeah, that's just the disclaimer, is watch out and be careful, be vigilant in the blockchain space, because there's a lot of really bad people that want to take your money also. Okay, is everyone thoroughly scared about building on blockchain? Okay, so what I want to do now, before we get started talking about kinds of things you can build on blockchain, I want to actually just vibe code an app. I want to put a voting app all the way onto a blockchain and let you guys vote again, but in a way that is censorship resistant and always on. So what we'll do is we'll use Scaffold-eth 2. Scaffold-eth is our tool of choice, and I'll just grab that here and we'll bring in a new terminal. Okay, so I'm at scaffold-eth.io. I've grabbed this command here, and I'll paste it in. And what are we going to do? We're going to be just vote. What if I say vote? Has anybody taken vote? Okay, cool. So I mentioned Hardhat and Foundry earlier. These are the two orchestration tools. These two tools are very similar, and you can use either one, and we give the choice. But basically, either of these tools help you to compile and deploy your smart contracts to a blockchain. And while we're working locally, they'll also spin a local blockchain up for us. So I'm just going to pick Hardhat because that's the favorite of the tool builders, and I know it's going to work the best out of the two, but either one works fine. In fact, if you're building a very heady smart contract that you need to put a lot of tests into, you might want to use Foundry, because Foundry lets you write your tests in Solidity, so it's just a little easier to test. But this is way down in the weeds here. Don't worry about it. Hardhat or Foundry are just as good for what we're going to do. We're just going to write a little bit and hit go, and hopefully it deploys. Okay, so let's cd into vote. That is, oh, no. cd into vote. There's our app. And what I'm going to do is I'll spin up a local blockchain. So at first, I don't want to deploy this all the way out to a blockchain. I want to run a local blockchain, and I want to deploy it there. And I kind of want to poke it a little bit to make sure it does all the things that I think it's going to do. So we'll run a local blockchain with yarn chain. Okay, that brings up a local blockchain. And then we'll have a dev... yarn start. We'll fire up a local Next.js dev environment. So that gives us a nice front end, okay? Whoa, look at my IP address. It's like bridged in here. That's pretty cool. Okay, and then the last thing I'll do is just a yarn deploy. And that's going to deploy a template smart contract to our local blockchain. There we go. Okay, so everything kind of comes up here. So this is Scaffold-eth. This is what our front end looks like. And this debug contracts tab is the most important. It kind of takes you to this nice UI. And this UI is basically representative of the smart contract. Let's get into the code real quick, and I'll show you that. Let's go look at the smart contract just for a second, okay? So we're supposed to be vibe coding here, but I want to show some stuff off first. Then we'll get the vibe code going. Okay, so if we go look at the smart contract, we have Hardhat and Next.js. Think of that like, here's your blockchain and here's your front end. But there's a contract here, right? This is your contract. Okay, that's the real original name we came up with. And it just has a bunch of data types. If you're a programmer, you can figure out Solidity very quick. You can tell that, we're tracking addresses, we're tracking strings, we're tracking bools. uint256 means it's an unsigned integer that's using 256 bits. So this is just a very, very big number, or it can be a very, very big number, right? And you can see mapping from address to uint. So the smart contract that comes with Scaffold-eth just has a whole bunch of stuff that helps you kind of get your footing, get your understanding of how Solidity works. But we don't want to do any of that. Let's just vibe code this thing, right? Okay, so I'm going to take that out of the context. Let's just start right here, okay? So really, let's just imagine that all I've done so far is just pull down Scaffold-eth, and then I'm going to bring up Cursor. If you haven't heard of Cursor, it's similar to VS Code, but it has Claude built in. Oh, we got Claude 4. I don't think I've ever used Claude 4 here. We're about to find out how well it does. My demo yesterday was with Claude 3.7, so maybe the computer actually has gotten smarter than me just now. Maybe we've achieved AGI just now. We'll find out in a little bit. So we were able to pull down Scaffold-eth, and now we'll prompt this. And the reason why this is going to work so well is the Scaffold-eth team has created this cursor rules file. So it's created a file that helps Cursor understand how to build on top of Scaffold-eth. So all you have to do is pull down Scaffold-eth and get to this point right here. And at this point right here, we can build anything we want. We'll just type it in, and hopefully it will run with it. So what do we want to do? Let's hold a vote that asks, how's the vibe, right? Okay. And we'll let anyone vote good or bad, and keep track of and display the vote. Let's see, there should be no owner or way to censor or shut down the vote. Okay, and that might be all we need, really. Smart contract? I don't think so. I trust Claude 4. Let's find out. Maybe so. We'll see. Let's see if it knows, oh, I'm going to store the votes in the smart contract. Let's see. Let's see how it does. Okay, here we go. So hopefully this thing goes to work working on a smart contract. Now, this is my first time ever using Claude 4 right in front of a whole classroom, so we'll see how this goes. Looks like right now it's sort of looking through the directories and learning how to do things. And now it's reading our contract. It's looking at a deploy script. It's still kind of getting context for what to do. Okay, vibe vote. It's creating vibe vote.sol. So we should have a smart contract that's going to show up here in a little bit. And hopefully it's an ownerless smart contract, right? Sometimes you can set up an owner, and the owner can do things like stop the vote or reset the vote. We don't want that, right? We want this to be censorship resistant. Why would we, have this beautiful decentralized system and then centralize it with a rule? We wouldn't want that. Okay, here we go. So so also it's putting the question on chain. Usually you don't want to put a bunch of strings on blockchain because it's kind of expensive. But in this way, it's really nice because I guess it's censorship resistant, and we'll just put it out on an L2. So we've got this question here. We're going to keep track of the votes. I don't know why we would need to keep track of total votes and bad and good votes. There's some things here that are going to cost a little extra gas. Maybe we could have told it, keep gas. Okay, so I should explain gas. Gas, you pay for every storage. You pay for everything you do on chain. So if your smart contract is keeping track of bad votes and good votes, you could just add those up to get total votes. So this extra total votes here is it's like, if you were building embedded hardware, you wouldn't have all this extra storage. This is expensive. So it was a little dumb here, but let's see how it does. Oh gosh, it's off the rails over here doing something. Let's just probably stop it and see where we are here. It looks like it's running yarn test. What's it doing here? Okay, let's just see how far it got. So the contract looks good. There's you can vote good, you could vote bad, you can get the results. A lot of read function here. What is this? Get the percentage. Okay, whatever. Let's go look at it. Let's go see how it looks. So our contract should be here, and we should be able to yarn deploy. Let's see if our contract deploys. Okay, and then if we go look at our front end, here is vibe vote. So we can get voter info. We can see if the voter has voted. We could vote good. Okay, so there's kind of these two actions. We can vote bad or vote good, right? And we could do this in this debug page, but if I move back over to the home page, hopefully it's created a UI for us. It has not. Let's see. Claude 3.7 was actually better at this than Claude 4.0. That's interesting. I wonder if I kick back. Let's see. You know what? I might do that. Let's grab this. And let's get reset. I find myself doing this every once in a while, okay? And then let's set this to Claude 3.7. Like, dumb it down a little bit for me, right? Where's Claude 3.7 here? Oh, no. Is it not even an option anymore? Okay, now I feel bad that I reset this. Let's see, continue and revert. What I want to do is also stop this and say, I guess please build a front end, bro. And I'll do Carlos's thing, but store the votes in the contract. Remember, it's expensive to store things in a contract. So be efficient. I don't know how to spell efficient. Okay, there we go. Let's try it again. A little bit of a hint. So when I'm doing vibe coding, I do a lot of this where I reset it and I try to give it a little bit better prompt and I try to one-shot it. I don't want to babysit the thing. I don't want to give it 3 instructions. I want to give it one really clear instruction and I want it to get the job done. So we're starting over from scratch here. It's going to have to list everything and look through everything again, figure out how to deploy. And let's see, does it start writing another contract? So it's looking at our contract. I'll replace the existing contract with vibe vote. That would be great. So basically, what does the solidity look like, right? If we were storing this in the most efficient way, there's probably just 2 counters, good and bad, and 1 mapping that says has voted, because we don't want to allow someone to vote twice. So basically, we just need to know, yeah, there it is. This looks much better. Has voted, right? Oh, accept, right? So we have, yes, this looks much cleaner, right? We have good votes, we have bad votes. We track whether someone has voted. An event is a good way to get like some off-chain information, but that's it. You don't need to do that. They start as 0 anyways. But then there's a vote good and a vote bad and some read functions, but this looks pretty good. Let me watch it a little closer. I feel like I was yapping too much earlier. Let me watch this closer and see why it went off the rails and see how we're doing. Let's see what it's doing. Okay, so it's working on the front end right now. Okay, so it's already got the vote built. It's probably working on this page right here now. So the page.tsx is that front end. So just to dig in a little bit more, this would be the front end that your users would use. And then this thing is a front end, this debug contracts page. It is a front end, but it's for you, the developer, to tinker, right? When you give this to an end user, you'll want to have your UI here. Okay, it looks like it's bringing in and fixing some linter errors. Sounds great. Oh, doesn't that look good? Oh, wow. What are we, surfing? It's like did a little like water emoji. How's the vibe, bro? Okay, so now it looks like we can cast our vote. Let's let this thing run for a little longer. It's going to fix some linting errors. Hayden, are you going to vote that it's bad again? We need someone to vote that it's bad just to prove that they can vote, so I'm counting on you, buddy. Okay, yep, it looks like it's, oh, what? It took the how's the vibe out? Let's see what it's doing. It looks like it's just like cleaning up a little bit. No, I don't want any tests. No, thank you. No testing. Whatever, let's let it write the tests, right? Maybe that'll be nice. This is a very principled agent. It likes to have tests first. Okay, and it looks like it's going to do things like, yeah, it's writing tests to make sure, if I vote, does the test work? If I try to double vote, does it not let me? It looks like it's fixing some types. I don't know what it's doing. Ooh, great. Yes, sir. Okay. Oh, you sent me a QR code and everything. Okay. Okay. Let's do that. Yeah. So, cool. So I'll grab this, and then I'll put this into, I'm going to go to eth.build and grab a QR code here. Okay, and then I'll paste this in. Okay, if you guys would like to scan this, this will be a Telegram channel. So if you'd like to ask questions later, you'd like to talk to us, you'd need to reach out to us for any reason. I'll bring this up a little later too, but jump into this Telegram channel if you would like to just have access to us in the future. We'll all be in there and we can help you get started. Maybe even we drop a little ETH base. Yeah, okay, Rainbow Wallet, that's a good point. So once you get this, if you don't have a wallet yet, go ahead and go to rainbow.me, and I think maybe we'll even put that into the channel. Okay, you put it already. Great. So go to the Telegram channel, get yourself a wallet, and then paste your address into the Telegram channel. And Philip will split out some ETH to all of you, so you can get some ETH, so you can go vote in our app once we get it going. I'll bring that up in a little bit. What's Claude doing back here? Okay, looks like it fired up a new front end. I'm going to terminate that. Looks like I fired up a new chain. We can terminate that. If I close this, okay. It looks like it's all done. Let's go see how it did. So here is our front end. Nope, no it isn't. What I need to do is fire that back up again. Okay, let's see. Do the contracts deploy? Yarn deploy. Okay. It looks like it is already deployed, and it prints out the votes are 0 and 0. But you can imagine all you have to do is go to Scaffold-eth, fire this up, give it a nice prompt, and you should have something like this, where you have the app up, okay? You can connect your wallet here, but at first you can just use burner wallets. So if I click this, it's just going to give me some money here. And this wallet right here, this 01C3B, this is a burner wallet. There's basically a private key in local storage. It's great for doing local debugging because you could just click, 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 and you don't have to worry about MetaMask pop-ups or anything like that. Don't worry about these two issues, whatever they are. Okay, so I'm going to go ahead and just vote real quick to make sure this works. Does Good Vibes works? It looks like there was a transaction. It looks like Good Vibes went up. Okay, let's see if I can vote again. It doesn't even let me vote again. Here, let's go to the debug page and vote again and make sure it doesn't let us. Okay, let's vote bad. It should say something like you can't. Okay, already voted. And then if we create, let's go to incognito, and I'm just going to spin up another front end, but what you'll notice is this is a different burner wallet. See how this dude is kind of like this kind of pink, and this guy's kind of teal? If I grab some funds from the faucet and vote bad, we want to double check that this increments right here. Good, it looks good. And now we have 2 total votes. Okay, of course, you would want to test your app a little bit more, but this is good enough for me. It seems like it's working. I think we're going to put this on chain. So I'll close that out. I would say we're ready to go here. What I want to do is get a terminal, okay? And we're going to yarn deploy. Are we going base? -- network base. So there's a handful of layer 2s to Ethereum. I don't know if y'all know what layer 2s are, but if you think of Ethereum like a blockchain itself, layer 2s are kind of like these little circles around it, where it's like an exact copy of Ethereum, but it's cheaper and faster to use. So we're going to deploy to an L2, a layer 2, instead of deploying directly to Ethereum. But we could easily deploy directly to Ethereum. It would just cost like 10 times as much. I'd rather pay a fraction of a cent since I'm deploying this silly little voting app. And in the same way that Ethereum is always on and censorship resistant, these L2s inherit that security with some caveats that they're on their way to be more decentralized, but there are some centralization risks with L2s, but don't worry about it. Don't worry about it. Let's go to base. Okay, so we're going to deploy to this base. We don't have any gas yet, so it's going to complain. Let me generate a deployer account. Bless you. And then let me put in a really bad password. Okay, so we just created an Ethereum account, and I'm going to fund that with some base, because we're going to have to pay real money to deploy to base. Okay, there we go. Looks like we're already on base, and I'm going to send money to this address. Okay, and we'll send just like 0.25, just like a quarter of a dollar. Very, very cheap. It should be very fast. Did that say it cost 8 cents? This may not work if that cost 8 cents. No, it didn't. Well, let's find out. Okay, now we're going to go deploy. Yarn deploy network base. And we put in our password. Okay, oh yeah, I think maybe something is happening on base and it's too expensive. Yeah. I think it has the money though. You're saying maybe the base didn't land? Yeah, it's there. We just don't have enough. I think something's happening with the network and it's more expensive because it said that it was 8 cents to send some money. So we'll just send a little extra. Yeah. Let's see. Maybe switch this. Maybe we'll send in a whole dollar. Let's send in $1 whole. Yeah, see, 3 cents. It said 8 cents earlier, I think. So sometimes when the network is very congested, it costs a little bit more to do this. Okay, now let's try one more time. Yarn deploy network base. What we're trying to do is put our smart contract out on a public network. Ooh, there it goes. Looks like it's trying now. Looks like we're going. There's a transaction hash. Okay, so our smart contract is now deployed to a public network. And technically, that smart contract should live there longer than I do. There's some caveats there with centralized sequencers and L2s, but Ethereum will always be on. Okay, the other thing I need to do is just switch our app over to using base. So let me grab the config file and set this to base and hit save. So now our whole app is on base, okay? And if I go to the home page, here is our app on base. And I'm using my real wallet, and I'm gonna vote. Now notice we're still on localhost, so I'm talking to the smart contract, but the application, the front end, is not deployed live yet. So first let me vote here to make sure it's gonna work. It's going to cost us 6 cents, which is very expensive in terms of an L2. I'm not sure what's going on, but there must be a lot of traffic right now on Ethereum. Usually that costs a fraction of a cent, like half of a cent or even like a fifth of a cent. But today it's quite expensive, but our vote was cast and it was not censored and anybody can read it. And let me show you that. Let's go look at the smart contract. So the vote is through. But let me prove to you that this smart contract is out here. And let me do one more thing. Let's do a yarn verify. And verify is this thing where it sends our source code up to a block explorer and it lets the block explorer compile it and make sure they get the same bytecode as the bytecode that lives on the chain. Basically, we're proving what the code is of our smart contract. So now let's go look at our smart contract on base. So this is base scan. It's a block explorer. And a block explorer is kind of like this disinterested third party. It's kind of like this website that lets you learn anything about what's going on the chain. We can tell, price of ETH, the latest block, how many transactions are going through. But in particular, we can see our smart contract. So here is the transaction of me voting for good. And we can see the good vote right there in the block explorer. This is a completely disinterested third party. It has nothing to do with our vote. We can even get in here and see the contract code, right? So when you're going to interact with the smart contract, you can get in here and see exactly what the code is doing. And the smart contract is always going to execute exactly what this code is, right? So if this was an important election, you would deploy this smart contract ahead of time and you would let lots of people get their eyes on it to make sure it's very secure. And then when the time came, everyone would be able to come in here and vote. And because it's a smart contract that lives on a blockchain, it's always on and anyone can get to it. Okay, so it looks like it's working. Everything is good. The last little piece I need to do here is a yarn Vercel YOLO prod. So what this does is push our app up into Vercel. So then we'll have a public website. So any of you will be able to go to this website and you'll be able to vote whether the vibe is good or not. But this is going to take about 5 minutes to upload the front end, so we've got a little bit of time to wait here. But the app is basically built. We were able to one-shot this. Well, it was more like a two-shot, right? We kind of had to reset that one time. But we were able to basically one-shot this app all the way up to a blockchain. And even though we put this on Base, we totally could have put this vote on Ethereum, and it probably would have cost us like $1 or $2 to put it on Ethereum, so it's not that much more expensive to use mainnet. Okay, so this is Scaffold-eth. This is the tool, Scaffold-eth 2, and you can get to it by just going to scaffold-eth.io. You run this command. There's docs. The GitHub is here. The tool is fully open source. But basically, all we did was pull this down, and we followed the instructions in the repo. Right? We did a yarn. Let's like zoom in here. We did a yarn chain and a yarn deploy and a yarn start, and then I opened up Cursor and I told it I'd like to build a voting app, and it built the voting smart contract and the front end for us in 2 shots. And now we're just kind of waiting for the front end to get deployed. And once the front end is deployed, anybody can get in here and vote. And yeah, that's Scaffold-eth, and you can get in here and use Scaffold-eth. So while that's going, it'll take a little bit to think. My next move is probably to go start explaining some of these challenges within Speedrun Ethereum. But let me pause there just for any questions from anyone. Do any of y'all have any questions about what we've talked about so far? Or even just questions about blockchain in general? You could even ask what kinds of shitcoins you should buy. That's a completely fine question. Ask anything. We've got a whole row of us here that are happy to help ask things, so please don't be shy. Any questions out there so far? Yeah. This is a really good point. So this is an inherent problem with blockchain and anybody being able to get to it and anyone being able to create an identity is you need some kind of Sybil resistance. So in this case, we would need to actually somehow find an identity system. Now, there are some scary identity systems out there. I think a really interesting one is WorldCoin. They have this orb that scans your eyeball and gives you an account based on that. Maybe that's the way it's going to go. I don't know. There could be other ways where somehow your government ID or your passport becomes an identity. Your passport has like an RSA chip in it that's signed by the government. You could use that to seed an account, and then the government can say only these addresses can vote. Some kind of like a whitelist system or something like that. But you've hinted at a very important problem within blockchain, which is Sybil resistance. And in this case, we could basically spin up a bunch of accounts, and we could have all of those accounts vote bad or all of those accounts vote good. And without an identity system, we're not sure about double voting. We know for sure that a single account can't vote twice, but that doesn't mean that you couldn't spin up a bunch of accounts and votes. So yes, there's kind of an elephant in the room here with this smart contract that you would need some kind of Sybil resistance or identity system on top of it. More questions? Yes, sir. Yeah. So Ganache is like a local blockchain, right? And Scaffold-eth brings in Foundry or Hardhat, which do have their own local blockchain. But Scaffold-eth is more of a tool for building apps and tinkering with Solidity. So as soon as you get Scaffold-eth up, you can deploy contracts, and then you can go to that debug tab. Where is that? Right here, this debug, this is kind of the secret sauce of Scaffold-eth. You can get in and you can kind of tinker with your contracts. So Scaffold-eth is for developers to, at first, just kind of learn how to write Solidity, but you've got everything here to deploy apps to production. It's meant Exactly. It's a local blockchain and orchestration that lets you deploy contracts and then a UI on top of it that auto-adapts to your contracts. So you kind of deploy a contract, tinker with it, deploy a contract, tinker with it, and then when you're happy, you deploy your contract and then deploy your app live, and you've got an application live. So it is for kind of like learning and trying things, but once you're good, you can deploy to production. And it's meant just as much for tinkering as it is for deploying production applications to blockchain. Cool? More questions? Yes, sir. Yes, there's quite a few apps that started with Scaffold-eth, but not a lot of them stayed. Like a lot of them built their prototype with Scaffold-eth, and then once they had that working and they had product market fit, they went with a more custom solution. So yes and no. Sort of like there are lots of apps that use Scaffold-eth to get initial product market fit, but once they do, they end up kind of rewriting some stuff or building custom indexers or building custom caches and stuff like that. Let me think of some. Yeah, I guess we have our own apps that we've built that are in production that do use Scaffold-eth. Also, I wasn't counting that, but that's a good point. We have a whole bunch of our own apps. ENS, yes, what is that? Grants dot builders dot ENS. That is a bad URL. I think I spelled something wrong there. There we go. Yeah, so this is like a grant program from a DAO, and they allow people to connect their wallet and apply for grants. And then on the other side, there's like an administrator wallet, and that administrator wallet can accept grants and send money to people. A lot of these are built by us, though. There's plenty of third-party apps that were built by Scaffold-eth, but I think in the long run, they like to rebuild certain parts to be more custom or just higher throughput scale kind of stuff. There's nothing particular about Scaffold-eth that's low scale or any problem like that. You certainly can, but so far most people have rewritten once they've gotten product market fit. Good question though. Yeah. Okay, how do we know that a user has voted? That's a cool question. So the way it stores it is in a mapping. Oh, look, there's our tests. Very nice. It's right. Let's go to our contract. Okay, so we're counting good votes and bad votes, but it's this right here. So this is a mapping of an address to a bool. So for any given address, we keep a Boolean. And as soon as they vote, we set that to true. So has voted gets set to true once you vote. And then we require that has voted is false. So you can't vote twice because once it gets to this line right here, it checks to see if you've already voted using this mapping right here, has voted. And if that is true, then you can't get in and vote again. So it's just a little storage slot for any given address. We keep a Boolean for them. Does that make sense? Yep, yeah, like a hash map. Yeah. No, go ahead. No, because it's a hash map, it's like a one-shot thing to get the index. Yeah. No, of course not, right? Like if you could modify this after deployment, then it becomes tamper. Yep. Now they do, okay, so there are some interesting smart contracts where they have upgrade patterns. There's this really funky one called the diamond pattern that is just like really weird. There's a way that you can delegate call, so you can say, this contract lives at this address, but I want to run the code from another contract and have it talk to my local storage. It starts to get really heady and weird. There's also upgrade patterns where you can upgrade a contract, but if you do that, it becomes tamperable, right? And so what they usually do is they have the upgrade pattern, but then they have like a multi-sig that controls the upgrade. And a multi-sig would be like, you need 3 out of our 5. Like if we set up a 3 out of 5, you would need me and Carlos and Zach to all sign off on it to make that transaction work. So at least it's a little bit decentralized and set up. But in that case, if you can upgrade a contract, it's the same thing as that ownership pattern I was talking about earlier. Why the heck would you have this beautiful decentralized technology and then, write the rules to centralize it again, or write any kind of way to destroy the contract? You don't want to build that stuff in. Good questions here. Great questions. Let's see. Has our app gone? Yes, our app is in production. Okay, so let me get this, and let me set up another QR code. Okay, and paste this in. Okay, so if you scan this, you should get the app that we built. And if you have some base, you could vote. You should be able to scan in here, connect your wallet, and make a vote. Everything good? You two are giggling too much over here. I'm a little worried. Yeah, so how's the vibe, right? Like I'm getting the voting app here. I can connect my wallet. Connecting my local wallet that I have on my phone. Okay, everybody got that scanned in? Who wants it? Scan in now if you need it. Grab that. Okay, then let's go back to the app so we can see it. Okay, so how's the vibe? It's 2 out of 2. We need Hayden to get in here and vote no. Okay, I'm connecting my wallet. Okay, I'm actually I'll vote bad. Oh no, it's me. Of course, I've already voted. Okay, someone vote bad so we can get at least one bad vote in there. Anybody? Looks like we still got some guys in the front working on it. Yes. Well, you need any of those specific. There's a whole bunch of different wallets you can use. What's that? If you hit the little wallet connect button, then it'll take you to a bigger list of wallets. I have a rainbow wallet on mine, and I think you have to hit connect wallet, wallet connect, and then rainbow. It's a little IDK. Oh, there we go. There we go. Okay, two bad votes is enough, you guys. That's good. That's good. All right. So yeah, so we were able to basically, so first of all, if you're using a centralized computer, if you're using any kind of centralized system, if there's any point of centralization, you have to understand that either power or the tech is centralized in any way. It can either be tampered with or it can go down. In this case, we then deployed our own smart contract and we put it out on an app. And sure, maybe someone could censor this app, but if we put the app out open source and we let anyone pull the app down and run it locally, then it doesn't even matter if the app is censored. The important part is that the smart contract is going to live there forever and it's censorship resistant and no one can take it down. So it's just a much better way to have an app that lets adversarial folks work together or coordinate towards some goal. Okay, yes, sir? Ooh, IPFS is a good one. Okay, also, on the lines of, hey, wait a minute, this is just a Vercel app, can Vercel shut it down? You don't have to do a yarn Vercel. You could do a yarn IPFS. And what that is going to do is push your whole app into a storage system called IPFS. And IPFS, let's just look it up, is, not Buidl Guidl IPFS, but pretty cool castles floating around. Let's see, let's just go IPFS Google search. It's an interplanetary file system. Basically, it's like this content addressable peer-to-peer storage system. Now, there's some caveats here where it's hard to incentivize folks to pin your content. So you almost would need this vote to be so important that lots of people around the world also are hosting this information. So even though I pushed it up to IPFS, basically all I did was host it on my own computer and make it available for other people. You would want lots of other people to download your app and also host it on IPFS. We call that pinning. You'd want to pin this in a lot of different places. But if you have a blockchain app that is backed by a smart contract on a solid blockchain, and then you deploy that app to IPFS and Vercel, then anyone should be able to get to that app, even if the worst of state actors was trying to censor you. And that's a good call with IPFS. Okay, more questions about maybe how this is working, what kinds of things we would put on chain? If not, I'll get into speedrun Ethereum soon, but yeah. I don't think I understand the question. So you're saying any given, can we ask that again?
I have Ethereum wallet.
Yeah.
I don't use some specific wallet, but I don't want to install software to my phone I don't trust, for example.
Mm-hmm.
Is there a simple mechanism to connect any Ethereum wallet, like any Ethereum address without reliance on specific wallet?
You could, but it's not good. The answer to that might be you would take your private key and put it into the other wallet, but I don't think you want to do that. You shouldn't be copy pasting around private keys. I think what you're saying is, I have an Ethereum address, but it's not in this wallet, and this wallet's only the one that's connecting to your site. How do I get this wallet into there? The answer is probably you don't, and you shouldn't do that. You should just create another wallet and send a little bit of your ETH over to this wallet. Does that make sense?
I'm actually talking about wallet as a software, like the
Mm-hmm.
software I use to manage my wallet in the Ethereum sense. I'm not that versed in Ethereum itself, but I'm not talking about wallet inside Ethereum. I'm talking about the app I use to interact with my wallet. Like if I want to have my keys on my device,
Mm-hmm.
I choose software solution that I found transparently, and then I want to connect to such an app.
Yeah, so you're definitely not connecting your private key into the app. The app has no control of that. So Wallet Connect basically connects into our app, but you can use any wallet to connect in. And what it's doing is it's not in control of your wallet. Like when I click, let me show something here. When I click to vote, let's connect. So this is Wallet Connect, right? I'll connect in and I'll choose MetaMask because I have a MetaMask right here. And it's connected in, but the wallet software is separate, right? So the wallet software is up here and it's an extension. And it's just connected into this site through a communication channel. And when I go to vote, it's just going to kick that transaction back to the wallet. So the wallet is waiting over here, and the transaction goes back to the wallet, and it stays in the wallet, and the wallet uses the private key to sign the transaction and then send it back to the application.
I understand that. I just asked if the connection in between the wallet and the app, if it's application specific or if there's some general API I can, if I write a wallet, I can use that API to connect for my users to be able to connect to all the apps.
It's Wallet Connect, right? I think the question here is, there's a couple different libraries in the space. There's Wallet Connect and Rainbow Kit, and these kits basically let you connect any wallet into your app. So this Connect Wallet button here is using that kit, and it lets us select any wallet. I still don't know if I'm answering your question. So, like, yeah. So how about this? So this is a wallet I've built. This is my own wallet. I control the code for it and everything. And I can connect this wallet that I've built myself into this app using Wallet Connect. Is that your question? Okay, so this wallet I built myself. I'm going to go to Wallet Connect here, and it's going to give me a QR code. So if I scan that QR code, this wallet that I wrote, I control the code for, is now connected into here. And when I vote for good, it's going to prompt here to say, okay, and here's the transaction details. Oops, it's on mainnet. I need to reload. Let me try that again. Okay, and then I'm going to sign the transaction in my own software. This is my software right here signing the transaction. That's it? Okay, cool. So I think it's Wallet Connect and Rainbow Kit is kind of the answer there. Yeah. Okay, more questions? Yeah. No, for sure. I mean, so I have mine in like autopilot mode, right? So it is just like allowed to do whatever it wants. Like I let it run local commands and everything. I just give that thing the thumbs up to just go. Sometimes that goes off the rails. Like it might like run a test and get an error, and then it's like, oh, I'm going to fix that by writing another test. Every once in a while, it just goes off the rails and goes a little crazy, and you want to stop it. And sometimes I even just like get reset hard the whole thing and start over again. I wouldn't say there's like a specific territory where you want to like slow down and stop. It's more like while I'm watching it do the thing, is it doing basically what I probably would be doing if I was a coder? And then if it's all of a sudden doing some crazy stuff, I usually stop it and try again. So it's more of a feeling of, ooh, this thing is definitely not doing what it should be doing. There's no specific, like, obvious, like, uh-oh, it's definitely not right. Does that sort of answer it? Yeah. I would say that a junior coder is going to prompt and then get the app back and then try it and see if it does what it wants to do. And if it's close, maybe provide one more prompt to get it there, or reset, give it a little bit more instructions, and then try again. Basically, don't even watch what it does, just wait for the result and then try the result and see if it does what you think it does. And as these models get better and better, it's going to get better and better at getting the right result. Does that answer that? Good to go? Okay, yeah. Ooh. What about what? The fun? Yeah, okay, so. Oh, okay. That is an existential question for sure. I love building things too. And you're right, there's a little bit less of that now. But I think if you think of this in terms of time and scale, this is scaling up, and it's, making, maybe you could do something else that's interesting. I thought you were talking about fun on blockchain, and I was about to go show you how to like gamble and with high leverage. But maybe that's what you could do, right? While the thing's writing the code for you, you could go do something even more fun, right? But that is absolutely right. How do you answer that, Shiv? I know you love coding, you love building things. As AI starts to take over and write some of the code for you, it does take some of the fun out of it. In fact, it makes it a little bit kind of sad and create a chilling effect. Like, as I'm writing code, I know that a computer could be doing this better than me. It's almost not fun anymore, right? How do you deal with that?
I enjoy it right now.
You just enjoy it anyways, okay.
I don't give full power to it.
Okay, 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 not me. Yes. Yes, you could be a little bit more in control, yeah. Okay. Do you want to do this? Can we confirm? Yeah, yep. Yeah. 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 Any more questions? Yeah. Someone else said this, but it was a really good quote. And they said something like, AI is not going to take your job. Someone using AI better than you is going to take your job. So I would say that, like, to answer that question, keep embracing these tools, keep using these tools, keep learning and keep building. If you have a big CV of all these different apps you've built on chain and you're keeping up with the latest models and you can vibe code, maybe the shift eventually is going to be all just one-shotting. But I think it's just about, like, keeping up with the trends and trying things. Who knows what the future will hold, though, and how fast this is going to come. Yeah, have I tried? I haven't tried Solana. I mean, I know of it and it's cool, but I am kind of a decentralization maxi. Decentralization is the most important part here, and Solana is only sufficiently decentralized, and it's not sufficient enough for me. But it's cool, and there's a lot of fun things on it, but it's not sufficiently decentralized. Yes, sir. Yeah, that's a great question. So every time I put a smart contract on the chain, there are tens of thousands of nodes all around the world that now have to download and hold that smart contract forever, right? And yes, that it gets bigger and bigger. To hold the entire chain right now, it takes like 3 terabytes worth of storage. And the bigger the chain gets, the harder it is to run a node, the less decentralized it is, right? When we look at Solana nodes, for instance, there's a lot less of them because it's way harder to run a Solana node than it is to run an Ethereum node. So this is definitely an interesting thing to think about, but it's part of the economics of the protocol. I paid money to put that out there, right? I paid something like 8 cents. And the market says that that's the fair market value for me putting that thing on all 20,000 of those machines and those machines holding it forever. So yes, like there is like some storage issues here where that storage is growing as everybody adds new things to the chain, but they're paying for it. And the people who are storing it are being rewarded for storing it. So there's an economic game there to make it worth it. I don't know if I totally understand that. So if you were putting a thing on a blockchain, you definitely don't want to put movies on a blockchain, right? Movies are huge. It was 8 cents to put like this much text on there, and that's like pretty cheap. And that was just one time. Yep. But if we were putting a movie on chain, it would be very expensive. So I don't know if that was your question. True. Yep, and that price is a variable that you store in the smart contract, and you can decide whether or not someone's able to change that variable with the code. But if you have the code written that says no one can change the price, and the price is X, then the price is always going to be X, and no one's going to be able to change it.
Maybe I have a follow-up question to the storage issue. Is there any progress on, well, it doesn't sound to me quite sustainable in the future, because I think the technology will scale exponentially, but the storage issue will get bigger and bigger. So if there is some progress towards, I don't know how to solve.
How much did a 1 gigabyte hard drive cost when you were born? Okay, it was expensive. How much is it now? Very, very, very cheap. Yes. Hard drives are going to get exponentially cheaper. You can get a 16 terabyte drive now for a few $100s.
Do you think it will be forever cheaper and cheaper? Because
I don't know. Yeah, maybe there's a plateau. Yeah. I don't know. But I know that that cheapness is growing faster than the size of the blockchain. And I know that the guys that came up with the protocol are way smarter than I am, and they've thought of this. But I don't particularly know for sure that that is the case. But my instincts are that storage is going to get cheaper and cheaper and cheaper, and the blockchain is only slowly growing. And also, we're working on light clients. We're working on ways with ZK proofs. If you haven't looked up ZK proofs and zero knowledge, definitely something to be looking up alongside with blockchain. Basically, blockchains and zero knowledge proofs are going to come together to create basically the new internet and new computers and how things work. They'll use zero knowledge proofs to take a whole bunch of information and compress them, or a whole bunch of or some secret information and prove it, and then a blockchain will be where you store it and go get it. So if you don't know about zero knowledge proofs, also put that on your reading list. But zero knowledge proofs are going to be used to create light clients where a lot of this information can be proved by having a small proof. Instead of having all of the information, you just have a proof, and you can use some moon math on it to prove certain things about certain values. So along with storage getting cheaper and cheaper, there's also new types of math and compression and proofs that allow us to store things for cheaper or hide things. Yes, sir? Mm-hmm. Absolutely. So going back to IPFS, really cool storage layer where it's content addressable, you can put anything there, you can pin it, anyone can come get it, it's all peer-to-peer. That's off-chain storage. So usually, and it's content addressable too. I know I said that a million times, but let me say it again. If I store a particular picture in IPFS, there's always going to be the same address or hash for that picture. If I upload that same thing somewhere else, it's going to have the same hash. So knowing that that hash can't change for the given content, then that's the address that you can go get that stuff from, and it never changes. So what you can do is you can take a picture and you can put it in IPFS, and you can get the hash back, and then you could put the hash on chain. And that'll never change. So then you can go to the smart contract and say, where is that picture stored? And it's not a URL, right? It's not somebody's web server. It's like a hash of the content in this other storage protocol that you know is distributed peer-to-peer. So then you can go ask any of those peers, given this hash, can I get the picture back? And then you get the picture back. And that's how NFTs work. Going back to speedrun Ethereum for a second, the very first challenge you do is an NFT. Let me just go to OpenSea, and we'll go find an NFT, and I'll go show you the stuff on-chain. Okay, pudgy penguins, sure. Okay, look at this little eye-patchy guy right here, okay? So this picture is worth $25,000. But it's not actually the picture. Basically, the thing that you own, there's an ownership record that says this guy's address owns this hash. It's basically just a hash that this person owns. And if you go follow that hash, it'll go to this picture. But this picture is not stored on the blockchain. This picture is stored in IPFS, or even worse, probably on some guy's web server. And when you go to the blockchain to see what you own, it's just a reference to that picture. Does that make sense? Yeah. Yeah. Yeah, let's go find out, right? Let's see. This thing should give us a smart contract. What's that? I don't want to go to the website. We should be able to find, well, what does this do? Ugh, yuck. That does look like a URL. Oh, okay, right here. Okay, so let's go back to ABI Ninja, right? We were talking about that tool that we built earlier. So we went to OpenSea and we found that pudgy penguin, and then we asked it, what is the smart contract that's controlling all this stuff? And then we went to a completely different service, and we'll paste that smart contract in, and we'll load it up and look at it. Loading. Loading. There it is. Okay, so this is the smart contract that controls the ownership for all of those penguins. There's probably 10,000 of those penguins, and they're probably worth $25,000 each. So you can imagine the amount of money that has gone through this smart contract, and it's ridiculous. And I'm sorry that that's what blockchain is being used for right now. But let's see if we could get the token URI. Here we go. So for token, oh, let's go back to that pudgy penguin. What's its ID? 6484. Okay, so Zach owns pudgy penguin number 6484, and we can put 6484 in here, and we can read back from the chain, where is the manifest? And look at this, it gives us that IPFS hash, right? So now we can go out to IPFS, and what I'll do is go to ipfs.io. Now what you need is to go to a gateway. I think I just do, nope. What I do is ipfs/that. Please work. That doesn't look like, there it is. Okay. Oh, that's all of them, isn't it? Slash, what was it, 64? Anybody remember 6484? Okay, /6484, go. There we go. There we go. So this is really what you own. Kind of interesting, right? This is worth $25,000. This is worth $25,000 to you? It's not worth $25,000 to me. This is worth $25,000, going market rate. But we can see in here also now there's an image, right? So we see the traits. It has a kimono brown, and it has normal skin, and it has a flat cap black on his head. Does it have a flat cap? Oh yeah, that's a flat cap. I didn't know that's what that was. Okay, and then if we wanted the image, we could just put this in, right? So this manifest stores information about the NFT, but also the actual image. Now finally, if I were to go to this, oh shoot, I have to do the thing again. Let's see, IPFS, oh gosh. ipfs/IPFS/ and then I'll paste that in. Okay, here comes the image. $25,000. So there it all is, right? So kind of some interesting stuff here. The stuff that's stored on chain is just a manifest with some text. It's just a JSON file. That JSON file is stored in IPFS. So the only thing you own is the hash that points to that manifest. And then that manifest gives you information about it and points to the image and all of that stuff. But hopefully that can't be changed or anything. I got some good questions here, yeah. Yes, the whole, no, we just needed to know the contract address and the token ID because it had the IPFS stuff there. You don't have to look through everything, right? We just had to we had to ask the smart contract, hey, given token 6484, where's the manifest? And then it gave us that back. Yeah, you think of it, yes, we had to find the smart contract. So it would be incredibly hard. Yes. Buried somewhere in some deployment, somewhere out there, is this smart contract getting created. Probably 3 years ago, buried somewhere in there in some transaction, someone deployed this smart contract. You're right, it's very hard to find. Yep, there's almost like you kind of had to go to OpenSea to find this smart contract in the first place. And thousands of smart contracts are deployed every day, so there's just so much noise there. If you were just trying to watch the chain and see it, you probably wouldn't. Yeah, good questions. We probably should, right? So along with civil resistance, we should have built in some kind of civil resistance mechanism. Maybe I have everyone here register their address, and then I would whitelist them. And you're right, we should also have a voting round. We should have some kind of period where voting is now open, and then at some point voting is closed, and then someone needs to poke it and close the voting and count the votes officially, right? There's no official point built in that smart contract at all. It's just kind of this open-ended counter. So you're right, if we were building a real vote, we would want to put in some timestamps where at this timestamp, anyone can click a button, get paid $10 to do it, so they're incentivized to do it, and also when they click that button, it counts the votes one last time, and there's an official, this is the person who won, or this is the vibe. Does that answer that question? No, I don't think so. No, okay, so the state of blockchain, there is some weird stuff there where it's called a reorg, right? Where a block gets mined, and then another block gets mined, and another block gets mined, but then somewhere back here, there were two chains. Okay, so this is weird blockchain stuff here, but let's imagine that the current state of the blockchain is here, and then a miner mines this new block, and this is the new state of the blockchain, and then another one mines the next one, but something really interesting happens for this next one. In Asia, someone finds this block and it's valid. And in North America, someone finds this block and it's valid. And it's simply due to network delays, we basically have a small split for a second, right? Now there's two valid blocks, there's two valid chains. There's almost like this divide of all these North American people believe that this is the blockchain, and all these Asian people think this is the blockchain. What happens next is whichever chain finds the next block is basically going to be the canonical chain, right? It's the longest chain is the canonical chain. So if a block is found here first, and as long as it propagates back before another block is found here, now it could happen again, right? And then another one, but eventually there's going to be a canonical longest chain. And let's say you voted, and on the Asian blockchain, your vote is in, but on the North American blockchain, your vote is not there. There could be some reorg where those few blocks aren't part of the chain. And as we pick one or the other one, some of those transactions may be lost because they're not mined into this chain, right? So what you want is, I can't remember, finality, I think is the word. And what you want is finality, that you know for sure that this is never going to be rolled back. And the way you do that in a proof of work system is just by depth. By the time that block is 10 or 15 deep, you know that it's never going to reorg. The way you do that in a proof of stake system is a little bit different, and I don't totally understand it, but we're getting finality down to a smaller thing. And with ZK proofs, I think there'll be fast finality where each block will be, I have no idea how this works, but it will be final with each block. But right now, I think there's like an epoch and there's a finalization. So yeah, a long way to say that the chain can reorg when it's only like a couple blocks deep. But by the time your transaction is 20, 30 blocks deep, there's no chance of a reorg. Does that make sense? Okay. Wait a little bit, yep. Especially if you're accepting Bitcoin. If someone pays you in Bitcoin, those blocks are 10 minutes long. And then, there could be a reorg, right? So if someone pays you like $10 in Bitcoin, who cares? First block that as soon as I see that $10 show up, I'm gonna give the guy, the goods. But if he's paying $10 million, I'm gonna make him stand there for probably 3 hours. And I'm gonna make sure that all those blocks are nice and deep. And then I'm gonna say, okay, here's the $10 million. Like you successfully made sure that block is deep, deep, deep in the chain and there's not gonna be a reorg. So it kind of depends on the value of the thing also. Yep. Yeah, okay. So resources for technical people. Well, first of all, just ethereum.org, eum.org. So this is a great spot. And there's almost too much information on this website. You can spend a lot of time looking through the information on this website. This is gonna give you a lot of just like, what the heck is going on, advanced stuff like running a node and zero knowledge proofs, how to use it, how to build on it. If you want to look specifically at how to write Solidity or how to write smart contracts, I really like Solidity by example. Solidity by example takes you through all these really good examples of how to do different things with the syntax, but also different kinds of applications you might write, different kinds of hacks that we've seen throughout the years. The EVM, Foundry, DeFi, lots of stuff here. So this is another good resource is Solidity by example. What else? You guys got some good resources you guys like to use? Ooh, yeah, how about that? If you search Web 2 to Web 3, and then maybe my name, how about that, Austin? You're gonna get this really cool curriculum that Carlos and Etta and I have prepared. But this is 4 weeks of videos that will take you through a long running, start from scratch. We talk about wallets, transactions, gas, dApps, ENS, DEX, all sorts of different concepts. And we kind of take you through it very slowly. And then we take you through Speedrun Ethereum also. What else? What else do you guys use? Ethernaut. Ooh, when you're ready to test your skills, Ethernaut. Yeah, I'll get that. No. Now that I know that, I'll go back to that. Yes. So the Ethernaut is this really fun challenge where you connect your wallet and you deploy a game, and it takes you through all these different challenges. Along that same line, we have CTF, as in capture the flag, .buildguild.com. So if you'd also like to try your hand at some of our security challenges, you can take on the Build Guild CTF. And this was written by the folks in the front row here, and there are some very hard challenges that I still don't know how to complete. More questions? That's pretty good. Maybe also you can ask us questions in that Telegram channel. Anytime in the future you were like, what was that old guy saying? Go back to that Telegram channel. Let me pull that up one more time, just in case. Go back to this Telegram channel. Is this the Telegram channel? Nope. This one right here. Scan that in and have that. Scan that so you have that. You can ask questions 3 years from now. You can ask a question in there. And as long as we all haven't made fuck you money and we're out of here, we'll be there to answer your question. Yes, sir. Ooh, you don't like Telegram. We got a cypherpunk in the crowd. Okay, what do you use, Signal? Yeah, I'll give you my Signal. What is it, my phone number? I don't want to give you my phone number either, right? How do I? Okay, let's do it. I don't know how I can, but let me see if I can figure out how to share a Signal. Maybe for my phone. What else? What else do you use other than Signal? Is Signal the way? Matrix. Yeah, I used to. Yeah. Let's see. How do I share? Okay. Oh, I think I'm close here. Which one of this is me? Account? Username. There we go. Oh. Let me see if I can set my username to Austin Griffith. That would be perfect. Austin Griffith 47? Fine. Okay, I'm Austin Griffith.47. How do I share that? I'll just put it up on the screen. So let's do a new one of these. Nope. AustinGriffith.47. Okay? That's me if you want to grab me on Signal, and I can send you messages there too. I appreciate a cypherpunk. That goes all the way back to good decentralization and good security. I'm just a very lazy cypherpunk, and I don't have enough money for anybody to steal anyways. Okay, more questions? Yeah.
Maybe if I can, one more follow-up question.
Sure.
I don't know if it isn't quite like specific to the issue of voting, like we discussed. There should be like end time when the
Yep.
Well, that would be then dependent on the node I would use to like execute the transaction.
The timestamp is based on when a block gets mined, the timestamp is part of that block. So the timestamp doesn't actually tick until a new block shows up. So the timestamp only increments per block, if that helps a little bit with that.
So I can find out the exact time, not from the node, but from
The blockchain, exactly, yep. And even if you're a little bit past time, as long as you get that vote in before that block comes in that's past the time, you're good.
So if somebody would like manipulate the node and change the time on this node,
No.
it wouldn't connect.
No, so a block isn't valid if the time is off by 15 seconds from the previous node. So there's something written into the protocol that says, I know that the last 5 nodes have been this timestamp. So if you try to put a block in with a timestamp that's too far away, it's invalid. So even if you dinked with the time on the node a little bit, you're only going to get a couple of seconds in any direction. And by the time you're 5 or 6 blocks deep, it doesn't matter. I was going to talk just for a second about things that work on chain. Is that okay? Or are we out of time completely? Okay, just a second. What I want to show here is just things that are working already, things that people are using. They're generally financial apps. A lot of times when we talk about making a transaction on Ethereum, there are times when Ethereum was so busy that it cost $50 to make a transaction on Ethereum, which meant that the only things that people were using were like very high financial things. Now this has gotten cheaper and we have L2s, so there's a lot more things that start to work. 5 years ago, you could never put Uber on chain, and you still really can't put Uber on chain, but we're getting closer to stuff like that. We're getting closer to Web 2 software starting to make sense on, not layer 2, but maybe layer 3, right? Another network that settles to this network that settles to this network that inherits all the security all the way up. But I want to show just the types of apps you might put on chain. And these apps are usually coordination mechanisms that are used between people that don't trust each other. So imagine all of us in this room don't trust each other. In fact, we hate each other. But we need to get together to buy a house. There's no way we could do that without a trusted central party, right? If there was a trusted central party, that would be easy. Everyone just gives me, the trusted central party, your money, I collect it and make sure there's enough, and I go buy the house. But you guys shouldn't trust me either, right? That's what's really cool about this system is you can write a smart contract and you could write the code correctly that all you have to do is trust the code. So a staking app is one of the first apps that you might build, or even like an escrow app. But a staking app would be, let's all buy a house together, and you guys each chip in your share, and there's some timestamp where we say the staking round ends, and there's rules that say if all of us stake and we're able to collect enough money, then go buy the house. And if we don't, if we defect, if someone decides not to stake, it's very, very important that everyone can get their money back, right? If somehow you're able to grief that smart contract and lock people's funds, that's very bad. Or if somehow you're able to steal someone else's funds, that's even worse, right? So when you're building a staking app, you're building this piece of code that can hold everybody's money, and the rules say if you get enough, we go buy the house, and if you don't get enough, everyone can withdraw their money back. And that's how this staking app works. A token vendor is how everybody's gotten rich. Basically, they deploy a token, they put it in a contract, and people can come in and buy that because of speculation and people thinking that token is going to have a higher value. People buy it low, and people rush in and buy this token and then sell it later to make money. That sadly is like a terrible kind of plague on blockchain, but there's a lot of speculation here. Games and randomness are particularly hard on blockchain because it's a deterministic system, right? You can see everything. It's public and deterministic, so randomness is particularly hard. But if you get in here and play the dice game, you're going to learn how you can do good randomness, but also how you can attack bad randomness. Basically, you'll build a smart contract that only rolls if it's going to win, which is a really neat kind of thing. And then a DEX is like one of the most important lessons here, and it's an automatic market maker. Basically, if you wanted to swap between tokens, or if you wanted to swap from ETH to a token, previously, the way you would do that is sort of through some escrow or through some order book, but all of those had some kind of centralization to them. When you build a DEX, you basically put reserves of a bunch of tokens and a bunch of ETH, and then you can trade between those two using the reserves, using a constant product price function. You'll have to get in and learn from it, but a DEX is a really interesting thing. One thing that's really interesting here is the more reserves you have, the better the swap is, or the less the slippage is. So you want to incentivize people to lock money up in there. So what they do is you write the rules to say, you can swap this for this, but you leave just a little bit behind to pay for the person who kept those reserves there. So if we think of a DEX or an automatic market maker, there's the code, and then there's people who provide the liquidity, and then there's people who swap. And all of these different people are just random people, and anybody can do this. So it's kind of like this public vending machine that anyone can supply the goods for and earn the fees on. Stable coins are a huge thing. It requires lending and some other things, but once you have over-collateralized lending on chain, which we have a challenge for and you guys can learn about, then you can create a stable coin. And stable coins are the biggest product market fit on Ethereum right now. And you can imagine that there are lots of countries in the world where inflation is plaguing their local currency. Stable coins stay stable. You can take your local currency, you can buy some of this stable coin, and tomorrow morning, your local currency will be inflated, but that stable coin will still be the same value because it's using some economic mechanisms to keep that coin stable. Prediction markets are also really interesting. You can set up a particular smart contract that says, I want to have a yes token and a no token, and you can buy either one of those tokens. And all the money for the yeses and all the money for the nos is pooled together. And if the answer ends up being yes, then all the people who bought no are out of their money, and their money goes to the people who bought yes. So you write a smart contract where you deploy two tokens with the eventual promise of basically rugging one of them and giving all the money to the other. And what that does is create this prediction market. People are financially incentivized to buy the answer that is correct, and you can see something like poly market, where all sorts of things are markets, right? Let's see, what kind of weird thing can we... How about US recession in 2025? Look at these odds. I mean, just in May, this shot all the way up to almost 70%, and now it's back down again. So people are basically speculating on a US recession, but you can watch these things and you can see where the probability of this kind of thing happening. And if you have insider information, you're incentivized to share that information by buying into the thing and making money. So this is how a market can actually predict future outcomes. Okay, and that's about it. There's a couple other things in here, but you can go to Speedrun Ethereum and try these out. Layer 2s, multi-sig wallets. We have a tech tree. We have a CTF. Tons and tons of content, but get started at Speedrun Ethereum. Try using Scaffold-eth to one-shot a few apps. Ask questions in that Telegram channel or on Signal. We're always available to answer questions, and I think we're going to hang out for another hour and see what's up. Thank you for having me.
So exactly, as you mentioned. One big thank you again to you, Austin, and actually thank you all for coming. And there were some beautiful questions here, so
Great
thank you all for them.